and it is this blunt triangular shape. As you notice on the drawing, there's no dimension for this top arc. That's because it's the same diameter as the outside of our part. Okay, so this arc is 1 inch 350 thousandths, and so it's a similar case on the other end. So that's going to dictate the width of our part along with the radiuses and the angles. So let's start by creating our circles on our sketch. So we're going to sketch on the top plane. Then we are going to draw a circle from origin out. Okay, we should be able to make that circle tangent to the model itself, and that will force it to be the same size. We're going to repeat that procedure over here. Remember, you want to highlight till you get the center so it automatically puts in the relationship. And in this case, you can actually just snap to the corner. And that's a reason not to put the fillets in yet. Alright, now let's look at our drawing. And we have a 50 thousandths wall on this pocket. Okay, so we're going to use the offset command. And we're going to pick, we don't want chains, so we're going to deselect chain so that we can just pick one line. And we want to flip the direction in this case. And it's going to be set at -50 thou. Okay, so we have one offset, and we're going to duplicate that offset on the opposite side. The value is 50, and again we got to flip it again. And now we have the borders without the corners. Now in this case, we have fillets wrapping around a fillet, so I am going to put sketch fillets in for these corners, matching the drawing, because we're going to have to come back, and if you look at the section view, we're going to put a fillet in the floor. So that needs to follow this other fillet. So we have an 8 times R190, and the 8 is these 4 corners, but on both sides of the part. Okay, before we can do the sketch fillet, we need to do some trimming. So we're going to trim the big circle back and its corners, and then do the same thing on the small one. Looks like I lost my reference, so let's just go ahead and dimension that guy. Oh, we got a big piece of circle left. So we've lost a reference for that corner that I thought was so great. Let's just go ahead and put a dimension in there. And it's that works. It's a 375 thousandths radius, which is half of what the diameter was. Alright, everything should look constrained like this before we start. Then we're going to go to the fillet command, and we're going to pick our corners, and let's set our fillet size at is 0.19 or 190 thousandths, and we're going to pick each of our corners. Right, so there we have our profile of our pocket. We didn't need to set the angle because it's already set from the major part using these offsets. Okay, so we're going to finish sketch, and let's look at it at a 3D shape. Should have a fully constrained sketch. Now we're going to extrude our pocket, and it's going to be a negative distance, and according to our drawing, if we look at the section view, it's 70 thousandths. Okay, so we're going to set that as -0.07, which gives us our depth, and we hit OK. Now, that pocket occurs on this side of the part and this side of the part, so we're going to do a mirror after we add the fillets to the bottom of this one. So we're at the point where we want to start adding chamfers and fillets. At the very end, we want to do our edge break fillets. So let's start by going through and adding our fillets. So we look at our drawing and go around the part. So let's start on the outside perimeter. This corner here is what? We look at the front view, and it's a R500, so it's a 1/2 inch. So we're going to go to fillet. We're going to pick those two edges as a pair, and we're going to set their size as 0.5, and then we can hit enter. Okay, so that's one discrete fillet. Now let's keep going around the perimeter. Over here, we have these corners here, inside corners. Let's look at our drawing. It says 125 typical, so anywhere it's not specified as a different size, we're going to put 125. So it'd be here, 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 and on the inside, I believe, these 4. So let's do those. We're going to go fillet. We're going to pick this inside corner, this inside corner, the top corresponding ones. And so that's 4 locations, and then we should have 1, 2, 3, 4. Now we have to put in the size, 0.125, and hit OK. So we should have all our fillets. Now you notice this one's not tangent. That's okay. It's tangent to the big arc, but not. It runs off. That's what we want. All our 1/8 inch fillets on the outside. All right. Now let's go to the next ones on the perimeter. We had 4 times 63 thousandths, which is a 16th. It's rounded up from 0.0625, but they give you some tolerance there. So that's just on the 4 corners of the hammerhead shape. So let's do that. I'm going to pick those 4 corners. And 0.063. So that's what our drawing actually says. Okay, so we should be left with a little tiny flat here and a larger flat here that allows us to measure that width. That's part of why I sized the fillets the way they are. We now have one more set of fillets. It's in the bottom of this pocket here. We're going to go ahead and do that. And in our drawing, if we look at the section view, it is also 630 typical. So that means it's typical. It goes all the way around. Sometimes you'll see all around like you do on this chamfer. But again, if it's typical, it's unless otherwise specified. Okay, so you can see in the section view that it cuts right through there. It goes all the way around the pocket, and you can see the tangency points in the front view. So let's go back to Fusion, and we're going to do a fillet. And we're going to pick the floor of our pocket, and we're going to do 0.063. And hit OK. And there's our finished pocket there. Now, this feature occurs on the opposite side of the part. It's handy that we made a plane that's now invisible. If we open the construction folder, that plane we used, we can use that to mirror. So we want to make it visible. Again, it's orange. And we are going to do a mirror. Now first it asks you, what do you want to mirror? So right now it says bodies. We actually want to do features. Okay? And the features we want to mirror is the fillet, and you have to hold the control key down, and our last pocket. That's what we want to mirror. Now once you do that, it's going to force these to be in a certain order. Perhaps these fillets should have come after the pocket, but that's how it works. Now, what are we going to mirror about? We're going to select our mirror plane, which is the plane we constructed the hammerhead type shape on. And if we look at the other side, you see a preview of our new pocket. And then we're going to hit OK. So we now have that pocket. If we modify the parent, the mirror will be the same. We don't need this mirror plane we mirrored about anymore, so we're going to go ahead and hide that. All right, next. Now we have chamfers to put on. We're going to put those on last. That way we can suppress them if we have trouble with them machining. And we have several on this part. Over on the right, we have our 620 thousandths countersink that I chose to put in as a chamfer feature instead. To calculate it, we need to subtract this number, the diameter, from this diameter, which just gives us the difference in diameter. With our calculator, we take our large diameter, 0.62, we're going to subtract 0.52. That gives us 0.1 or 100 thousandths. Divide that by 2. And our chamfer for this feature is 50 thousandths. So let's go back to Fusion, and we're going to do a modify. We're going to do a chamfer. We're going to select the top and bottom edge. And our size is 50 thousandths. And okay. So that's a pretty healthy feature, pretty large chamfer. Now, let's work on the inside. We have these two teeth, and they each have a chamfer on them. If we go down and we look in the section view, it's a 2 times 800 times 45, 2 times 80 by 45 chamfer. 2 places, so the places here and up on the other side of the part. Okay, so we're going to go back and do those. So we're going to go back to modify, and we're going to go to the chamfer tool, and our first one is on this bottom edge, and then we have another one, according to our drawing, is on the top edge. So that'd be this edge. And we're going to set our chamfer at 0.08, and then we get our nice little edge is going to fit underneath the bottle cap, and we pry with it. It also creates clearance for the bottle on the opposite end that's not prying against the cap. What else do we have as far as chamfers? If we look at the inside rim here, there's a different size to give it some clearance. So we have a 2 times 30 thousandths, 45 all the way around. That doesn't include this flat because it's already there, but it's going to run around this rim on both sides of the part. So let's make that. So we're going to go to modify, we're going to go to chamfer, we're going to select the top edge, and we're going to select the bottom edge, and it's going to be 0.03. So now we have a nice healthy chamfer here to smooth out on the edges of where our bottle is. It technically is the same angle as here, so it's not going to cut anything along there, and we didn't select that edge. All right, what's left? Edge breaks. Okay, so this is where different shops handle things differently. In some places, they're going to machine everything. They take the burrs off so they don't have to do finish work. We have a tumbler. A lot of shops will throw everything in the tumbler. So we're going to put these chamfers on last because we might suppress them or we might not cut the part that way, but it gives us the options to do that. If we look at our drawing, the overall note says deeper all sharp edges within 10 thou max. So they can't be any bigger than 10 thousandths. Okay, so that's what all these small little chamfers are that you see all over the part. They pretty much occur everywhere that hasn't already been broken. So go to modify, we're going to go to chamfer, we're going to start selecting edges. So you could select this entire hammerhead edge on both sides. Then we can select the outside edge of the part. And we can select this pocket, although I don't think it's wise to try to chamfer that with a tool. You have a high chance of the tip gouging into our fillet. So we're going to leave that one off. And again, if we have problems with Fusion, it's actually easier to use a chamfer tool without them modeled. And that's why we're doing these last, so we can come back and suppress them in the model and cut them with parameters. But you have to be real careful in Fusion that you're punching the right numbers. And if you receive this part from a client in a third-party software, you're not going to have the opportunity to suppress those chamfers. That's okay. There we go. We've just finished modeling the bottle cap opener. That might have been a little quick, but hopefully that works for you, and we'll catch you on the next one.